we'll discuss about the third method of finding the solution of a linear equation. That is the elimination method. So before we start, let's first have a review. A solution of a system of linear equations is a point or the set of points that satisfies all linear equations in the said system. And one way to find the solution is through the graphical method. Another way is through the substitution method, which we have already discussed last time. We will be talking about the third method, which is what we call the elimination method. Illustrative example number 1. I am thinking of two numbers. Their sum is 24, and twice the larger number minus the other number is 27. What numbers am I thinking? So first, let's assign variables to the unknown of this problem. That is, x be the larger number and y be the other number. So let's translate now the verbal statements of this problem into algebraic equations. The first equation is that their sum is 24. So since we know that the numbers are x and y, we can say x plus y is equal to 24. And we name that equation 1. The next statement to be translated into algebraic equation is twice the larger number minus the other is 27. Since we know that the larger number is x, twice of x minus y is 27. And we write that as 2x minus y equals 27. And we name that equation 2. We solve this system by cancelling the variable y. We can notice that the y in equation 1 and y in equation 2 are additive inverse of each other. So to cancel them, we can just simply add equation 1 with equation 2. We get 3x is equal to 51, and we name that equation 3. We divide equation 3 by 3 to get x. So the x therefore is 17. Substituting equation 3 to either equation 1 or 2, let's say equation 1, x plus y is equal to 24. And since we know from equation 3 that x is 17, we can write 17 plus y is 24. Y therefore is 24 minus 17, hence y is 7. So the two numbers are 17 and 7. But we can also solve this by cancelling the other variable, which is x. And since x in equation 1 and equation 2 are not additive inverse of each other, we make 1 the additive inverse by multiplying one equation by a constant. Let's say negative 2. And we get negative 2x minus 2y is equal to negative 48. Now we can simply add both equations because negative 2x and 2x are additive inverse of each other. We can get negative 3y is equal to negative 21, and we call that equation 3. To get y, we divide negative 3 to both sides of the equation. That is, y be equal to 7. Substituting y equals 7 to either equation 1 or 2, let's say equation 1. Since we can write that as x plus 7 equals 24, x equals 24 minus 7, hence x is 17. So the two numbers are 17 and 7. So let's have another illustrative example. Mr. Xavier received an order of 25 poultry animals and 25 dairy animals from Mr. Jan. In his farm, he knows that twice the population of poultry animals and thrice the population of dairy animals is 270 animals all in all. Also, each poultry animal consumes 2 servings of feeds, each dairy animal consumes 5 servings of feeds, and the whole farm consumes 300 servings of feeds per day. How many poultry and dairy animals are there respectively? Can Mr. Xavier supply the orders of Mr. Jan? The important statements found in the problem. So let's assign variables for the unknowns. Let x be the population of poultry animals, y population of the dairy animals. So the first statement to be translated is the statement twice the population of poultry animals and thrice the population of dairy animals is 270 animals. We can write that as 2 of x plus 3 of y is 270, and we call that equation 1. The next statement is about the servings eaten by each animal, and we can write that as 2 of x plus 5 of y is equal to 350, and we name that equation. Let's cancel x. We should multiply negative 1 to either equation 1 or equation 2 so that we may cancel the x's in the both equations. Let's say multiply negative 1 to equation 1, and that will mean negative 2x minus 3y is equal to negative 270. And let's copy equation 2. Now we are ready to add equation 1 and equation 2. We get 2y is equal to 80. To get y, let's divide both sides of equation 3 by 2. Y therefore is 40. Substituting it to either equation 1 or equation 2, let's say equation 1, 2x plus 3y is equal to 270, and we know that y is equal to 40. So we can write that as 2x plus 3 times 40 is 270. 2x then plus 120 is equal to 270. 2x is equal to 270 minus 120. 2x is equal to 150. Let's divide both sides by 2. X therefore is 75. So to answer the question, how many animals of each kind are there? There are 75 poultry animals and 40 dairy animals in Mr. Xavier's farm. And yes, he can also supply the orders of Mr. Jan. Now let's have the third illustrative example for this video. A tall teller in Inaj Road lost his copy of the vehicles that used Inaj today. He knows that the toll fee for bikes is 30 pesos, tricycles is 40, and cars is 70 pesos. He also knows the following information. There were 100 vehicles all in all. There is a total of 340 wheels counted in the wheel counting machine. And the total toll collected for today is 5,500 pesos. How many vehicles of each kind used the Inaj Road? Written for you the important statements of the problem. But first, let's assign variables to the unknowns. Let x be the number of bikes, y be the number of tricycles, and z be the number of cars. So the first statement to be translated is that there were 100 vehicles all in all. So the number of bikes, tricycles, and cars is 100. That can be translated as x plus y plus z is 100, and we name that equation 1. The next statement is that there were a total of 340 wheels. Since we know that a bike has 2 wheels, a tricycle has 3 wheels, and a car has 4 wheels, we can write that as 2x plus 3y plus 4z is equal to 340, and we name that equation 2. The last statement to be translated is that the toll fee collected for today is 5,550. And since we know that each bike pays 30 pesos for toll, a tricycle pays 40 for toll, and a car pays 70 pesos for toll, we can write that as 30x plus 40y plus 70z is equal to 5,500, and we name that equation 3. Now, solution. To find a solution for a system of linear equation that has 3 variables and 3 equations, we can have it grouped into 2 systems. Let's pair equation 1 with equation 2. The other pair is equation 2 and equation 3. Let's x in both of the systems. So we have to multiply negative 2 to equation 1, and that would give us negative 2x minus 2y minus 2z is equal to negative 200, and let's add that to equation 2. We get y plus 2z is 140. In the second system, we can also multiply negative 15 to equation 2, and we get negative 30x minus 45y minus 60z is negative 5,100, and we can add that to equation 3 to get negative 5y plus 10z is equal to 400, and we name that equation 5. Now this time, let's treat equation 4 and equation 5 as another system of linear equation. We cancel y in the systems. So we multiply 5 to equation 4. That would give us 5y plus 10z is equal to 700. And we add that to equation 5 to get 20z is equal to 1,100. Let's divide both equations by 20, and we get z is equal to 55. Substitute z is equal to 55 to either equation 4 or equation 5. Let's say equation 4. Since we know that z is 55, we can write that as y is plus 2 times 55 is equal to 140. Y plus 110 is equal to 140. Y is equal to 140 minus 110. Y then is 30. Now, we substitute z is equal to 55 and y equals 30 to either equations 1, 2, or 3. Let's say equation 1. X plus y plus z is equal to 100. And we know that y is 30 and z is 55. So we can write x plus 30 plus 55 is equal to 100. X plus 85 is equal to 100. X then is equal to 100 minus 85. Hence, x is 15. So the answers are x equals 15, y equals 30, and z is equal to 55. Thus, there are 15 bikes, 30 tricycles, and 55 cars that used the enlarged road for today.
I hope you learned something today. Till next video!